Yeah. So once again, good afternoon. Welcome to the lecture 2 of hydraulics and hydraulic machinery. So we are in the unit 6. So in this class, we'll discuss about the reciprocating pumps. So in the previous lecture 1, we have discussed about the centrifugal pumps. So in this session, we'll discuss about centrifugal pumps, reciprocating pumps, multi-stage centrifugal pump, right? One second. Every time's a problem. Okay. So if you see here the reciprocating pump, the multi-stage centrifugal pump. So multi-stage means simply ఒకటి కాకుండా multiple గా 2, 3, 4 like that. So if you see the single reciprocating pump, single centrifugal pump, so దానికి సిరీస్ లోపల అటాచ్ చేసుకుంటూ పోతే there is nothing but a multi-stage centrifugal pump, right? So if you see the initial class, one second. Yeah. So for this derivation, we'll see one problem here. So the diameters of the impeller of a centrifugal pump at the inlet and outlet are 30 centimeters and 60 centimeters. Determine the minimum starting speed of the pump if it works against the head of 30 meters. So what's the given data? So early also I said that. So any problem if you get in any subject, if it is a problematic in any subject, second year, third year or fourth year, so read the question 2 or 3 times. Tarvata first write the given data. So if you have any figure, draw the figure, right? Write the given data, draw the figure to find ఏం కనుక్కోవాలి ఇక్కడ ఏం కనుక్కున్నాడు determine the minimum starting speed. So to find the starting speed of the pump, whatever the formulas based upon the given data, whatever the formulas, write the formula, దానికి సంబంధించిన మినిమం క్యాలిక్యులేషన్ డూ ఇట్. అండ్ ఇఫ్ యూ డోంట్ నో ద ఆన్సర్, ఇఫ్ యూ డోంట్ నో ద బ్యాలెన్స్ థింగ్ రిమైన్, లీవ్ ఇట్. దెన్ అకార్డింగ్ టు ద క్వశ్చన్ ఎవాల్యుయేషన్ అండ్ ద మెయిన్ ఎగ్జామ్స్, సో ప్రతి క్వశ్చన్ మీరు మెయిన్ ఎగ్జామ్ పేపర్లో డోంట్ నెగ్లెక్ట్ ద ఎనీ క్వశ్చన్. చాయిస్ కాకుండా ప్రాబ్లమ్స్ చేయాలన్నప్పుడు డోంట్ నెగ్లెక్ట్ ఎనీ క్వశ్చన్. రైట్ ఫస్ట్ ద గివెన్ డేటా, ఫిగర్ ఉంటే ఫిగర్ వేయండి, నెక్స్ట్ ఫార్ములాస్ వేయండి, టు ఫైండ్ ఏంటి అని రాయండి, ఆన్సర్ వస్తే చెయ్యండి, లేదంటే లీవ్ ఇట్. బట్ ఎంటీగా ఏ క్వశ్చన్ కూడా మీరు వదలొద్దు. వై? బికాస్ మీరు మినిమం డేటా, గివెన్ డేటా, ఫిగరు, ఫార్ములా, టు ఫైండ్ ఏంటి అని రాస్తున్నే మినిమం 3 or 4 marks you will get out of 8 marks, right? So if it is a 14 marks question, you will get more than 50%. So atla every question if you write the given data clearly, figure, to find formula, so 5 questions kabatti part B lo 5 3s are 15 marks. So theory మీరు minimum 10 to 15 marks రాస్తారు. So that easily you will get 30 marks, so that you will pass the subject. That is a simple technique, right? So here the diameter inlet is 0.3 meters, diameter outlet is 0.60 meter. Then what is the head here? 30 centimeters. Now what is to find the minimum starting speed n? Therefore from this formula, from this formula HM, from this formula, this is a formula, right? So what is u2? So diameter ichadu kabatti, based on that initial velocity pi d n by 60, that is a value. u1 value pi d n by 60, that is a value. Therefore half 2g, so idi kada half 2g, half 1 by 2g, that is 0.3141 didi, divided by 2g, 2 into 9.81 value you got. So finally దీంట్లో నుంచి ఇది మైనస్ చేస్తే you are getting the value. So finally n square is equals to, so keep on substituting these values, so finally you get the n value is this one. Got it? Next problem. The diameter of the impellers of a centrifugal pump of inlet and outlet are 30 centimeters and 60 centimeters. The velocity of flow at the outlet is 2 meters per second, and the vanes are the setback at an angle of 45 degrees. Determine the starting speed. So ఇక్కడ యాంగిల్ ఇచ్చాడు కాబట్టి సో ఫార్ములా వేరేది యూస్ చేయాలి. What is that? What is that? That one tan pi is equals to, right? This is a formula. So first write the given data, d1, d2. What is the flow at inlet? 2 meters per second. What is the inlet outlet angle? So outlet angle, inlet angle, మీరు వెలాసిటీ ట్రయాంగిల్స్ చేస్తున్నప్పుడు ఏదైతే నొటేషన్ వేశారో అయ్యే వేయండి. ఇఫ్ యూ చేంజ్ ఇట్ సో మీకు మళ్ళీ ప్రాబ్లం మళ్ళీ తేడా వస్తుంది, రైట్? సో దట్స్ వై అవుట్లెట్కి ఒకటి గుర్తుపెట్టుకోండి, ఇన్లెట్కి ఒకటి గుర్తుపెట్టుకోండి, రైట్? నౌ వాట్ ఇస్ ద మానోమెట్రిక్ ఎఫిషియన్సీ? 70%. దెన్ బై టేకింగ్ ద ట్రయాంగిల్ అట్ ద అవుట్లెట్ ఫార్ములా, సో ఇన్లెట్ కనుక్కోమన్నప్పుడు ఇన్లెట్ ఫార్ములా వేయండి, అవుట్లెట్ కనుక్కోమన్నప్పుడు అవుట్లెట్ ఫార్ములా యూస్ చేయండి. Now taking the outlet formula, this is a formula, right? So after taking these formulas, cross change these values, so you'll get the values like that. Therefore, after keep on solving by using the minimum starting speed formula, n is equals to this one. Substituting the values directly, so you are getting the value is this one. Therefore, n is equals to 118 divided by 0.86. Yeah, 1.866 n minus n కాబట్టి 0.866 వస్తుంది. సో డివైడ్ చేస్తే దట్ ఈస్ 137.22 rpm, రైట్? Now if you see the multi-stage pumps, already మనం దీని గురించి క్లాస్లో కూడా చెప్పుకున్నాము. So the centrifugal pumps consist of more than 2 or 3 or 4 impellers, then the pump is called the multi-stage pump. Simply the pump is called multi-stage pump. The impellers may be mounted on the same shaft or a different shaft. So ముందు ఫిగర్లో ఎలా ఉంది చూడండి. So here the shaft is single shaft, the impellers are placed on the same shaft. So here we can interchange. Okay, shaft మీద you can have the same 3 or 4 impellers, or you can change the shaft also. You can change the shaft. So the multi pump has the following two important functions. What are the two important functions here? The two important functions of multi-stage pumps are to produce a high speed, to produce a high head, to discharge a large quantity of liquid. To produce a high head and to discharge large quantity of liquid. If the high speed is developed, the impellers are connected in series. This is simple logic. If the high speed is required, if the high speed develop అయితే, then the impellers are connected in series. అంటే series అన్నప్పుడు ఒకే షాఫ్ట్ కి ఇంపెల్లర్స్ అనేది అటాచ్ అయ్యి ఉంటుంది, రైట్? ఒకే షాఫ్ట్ కి ఇంపెల్లర్స్ ఆర్ ఫిక్స్డ్. And while for the discharging of large quantity of liquid, the impellers are connected in parallel. Simple thing. So ఈ సెకండ్ ఫంక్షన్ తీసుకున్నప్పుడు parallel గా ఉండాలి. Whenever the high speed develop చేసేటప్పుడు సిరీస్ లో ఉండాలి. Now taking the multi-speed pumps for high speeds అంటే obviously it is in a parallel connection. High speeds అన్నప్పుడు the impellers are arranged in series. Got it? The impellers are arranged in series. Simple thing. High speed, high head కావాలన్నప్పుడు to produce high head, the impellers are arranged to the shaft in series. If you require the large discharge of large quantity, then the impellers are arranged in parallel, right? Now see the figure. This is the shaft. Each shaft key, the impellers are arranged in series. See the number of impeller 1, number of impeller 2, the pipe delivery outside, right? So this is a suction, this is a delivery, this is a delivery. The remaining theoretical concepts you can easily understand by reading the concept, okay? So by considering the figure, when you want to see the produce high head, let us consider n is equal to small n is equals to number of identical impellers mounted on the same shaft. Small n is number of identical impellers mounted on the same shaft. Then HM is equals to head developed by each impeller. Therefore, the total head developed is equals to n into HM. That is number of identical impellers into head developed by the each impeller. The discharge passing through each impeller is same, right? Now the multi-stage pumps for high discharge. So multi-stage pumps two functions ఉంటుంది. First function is to produce high head. Second function is to produce high discharge. High discharge చేస్తున్నప్పుడు the impellers are arranged in parallel. Whenever the high head వస్తున్నప్పుడు the impellers are arranged in series. Keep that in mind. Okay. Next. Whenever the multi-stage centrifugal pumps for a high discharge. For obtaining the high discharge, the pump should be connected in parallel, as already described. So parallel ki meer figure వేయాలన్నప్పుడు draw the figure like this. Pumps in parallel, pumps in series. Got it? So ఇది ఒక షాఫ్ట్, మనకి ఇది షాఫ్ట్ మీకు ఫేసింగ్ టువర్డ్స్ యూ, అందుకే షాఫ్ట్ ఇలా కనిపిస్తుంది రౌండ్ గా. షాఫ్ట్ ఇక్కడ ఒక షాఫ్ట్ ఉంది, ఇక్కడ ఒక షాఫ్ట్ ఉంది. ఇక్కడ సంపులోంచి వాటర్ పైకి వెళ్తుంది, ఈ సంపులోంచి వాటర్ పైకి వెళ్తుంది. So these two are connected. The outlets are connected to the same pipe, that is Q1 plus Q2, right? Q1 plus Q2. Discharge outlet is Q1 plus Q2. Here is a pump 1, there is a pump 2. So for obtaining the high discharge, it's okay, same way. Now see the same thing. Let N is equal to number of identical pumps arranged in the parallel. So ikkada pumps arranged in a parallel, ikkada impellers are arranged in a series. Now Q is equal to discharge from one pump. Therefore, the total discharge is equals to N into discharge. So based upon this formula, this derivation, you are having some problems for this multi-stage pumps. Now see here, question lone three-stage pump annadu. Now I have to keep N is equal to 3. Ee problems already మనం solve చేసాము class లో. Once again remain చేసుకోండి. Keep your running notes. Okay. A three-stage centrifugal pumps has impellers 40 centimeters and diameter 2 centimeter wide at outlet. So this is a question. So what first write the given data. E given data మీరు correct గా రాసారంటే neat గా minimum 2 marks will get in the main exam. Mid exams వదిలేసేయండి, that is no problem. But in the main exam, every time I will repeat you. Given data neat గా ఇట్లా మీరు neat గా detail గా రాసారంటే 2 marks given data, 2 marks problem, 2 marks you are solving, 1 mark for your formulas. Like that you will get minimum 3 or 4 marks if you don't know the answer also. If you don't know the formulas kuda given data ni batti meer formulas edo okati chestu vellandi, you will get some sort of calculation. So calculation chesinanduku gaanu you will get minimum 4 to 5 marks, right? Now what is the given data? Number of stages 3 ఇచ్చాడు. Diameter of the impeller at outlet is 0.4. Width of the outlet is 0.02. అవుట్లెట్ కి ఎప్పుడైనా నేను ఇందాక చెప్పాను కదా, నోటేషన్ గుర్తుపెట్టుకోండి. ఇన్లెట్ కి ఒక యాంగిల్ ఇవ్వండి, అవుట్లెట్ కి ఒక యాంగిల్ గుర్తుపెట్టుకోండి. నౌ రిడక్షన్ ద ఏరియా ఆఫ్ అవుట్లెట్ ఈస్ 0.1. దేర్ఫోర్ ఏరియా, సో డయామీటర్ ఉంది కాబట్టి ఏరియా కనుక్కోండి. ఏరియా ఆఫ్ ద అవుట్లెట్ ఈస్ దిస్ వన్, 0.9 into pi dt into B2. So value is this. Therefore, manometric efficiency is 0.90. Overall efficiency is equal to 0.80. Then what is the speed of the impeller? The speed of the impeller is 1000 rpm. Therefore, the discharge Q is equals to 50 liters per second. 50 liters per second. Discharge Q is equal to 50 liters per second. Then what is the thing you have to find? Determine head generated by the pump and the shaft power. Now outlet అన్నాడు కాబట్టి outlet formulas తీసుకోండి. VF2, right? VF2 is equals to velocity is equals to discharge by area of flow. ఈ minimum basic formulas మీరు గుర్తుపెట్టుకోవాలి, right? Discharge అంటే ఏంటి? Area into velocity. Velocity అంటే ఏంటి? Discharge by area of flow. So discharge మనకు తెలుసు, area of flow మనం ఇందాక కనుక్కున్నాము. So that is a 2.21. Now the tangential velocity of the outlet. Tangential velocity U2 is equals to pi d2 n by 60. So you will get the value this one. Now from the free velocity triangle at the outlet, so this is the formula, right? Tan pi is equals to Vf2 by U2 minus V. W2. సో ఇలాంటి ఫార్ములాస్ మనం వేసి ప్రాబ్లమ్స్ కూడా మీరు ప్రాక్టీస్ చేశారు. మీరు ఒకసారి చెక్ చేసుకోండి రన్నింగ్ నోట్స్. Therefore దీన్ని తీసుకురండి, దీన్ని కిందకి తీసుకురండి. There will you will get 2.21. Therefore VWT is equals to U2 minus 2.21, that is 18.73. Therefore so above equation మనం సాల్వ్ చేసిన ఈక్వేషన్ లో manometric efficiency గురించి మనం డిస్కస్ చేసుకున్నాం. Now take the manometric efficiency, this formula, okay. Now substitute this one, you are getting HM value is equals to 35.98 meters. Now using the equation for the total head generated by the pump, N into HM. N into HM ekkada తీసుకున్నాము? Now indaga multi-stage pumps, this one, right? For this one, applying here 3 into 35.98, that is equal to 107.94. Then what is the power output of the pump? Weight of the water lifted into total head by 1000. Weight of the water is equals to rho into G, right? Rho into G into Q. Total head is equals to 107 divided by 1000. So what is the rho here? Water kabatti 1000 తీసుకోవాలి. Specific gravity G is equals to 9.81. So ఇక్కడ rho value, if it is instead of water మీరు ఏమైనా ఆయిల్ తీసుకోవాలనుకోండి, specific gravity something 0.9 ఇచ్చారనుకోండి, then you have to write rho is equals to 1000 into 0.9. మనకి ఇక్కడ ఆయిల్ లేదు కాబట్టి ఓన్లీ వాటర్, సో డైరెక్ట్లీ we have to rho into G into Q. Therefore 1000 into 9.81 into 0.05 into 107. So after substituting we'll get the value. Now by using the equation, what this overall efficiency is equals to power output of the pump divided by power input of the pump, that is this by shaft power. Therefore shaft power is equals to, so cross cheyandi దాన్ని తీసుకొని దీన్ని తీసుకొచ్చేస్తే, so finally you are getting 52.94 divided by 0.80, that is 66.175 kilowatts. That is the answer. సో ఇట్లా మీరు చేసుకుంటూ వస్తే 14 మార్క్స్ వస్తుంది. ఇలా రాయకపోయినా మినిమం ఫార్ములాస్ వేసుకుంటూ ఏదో చేసుకుంటూ వెళ్ళినా కూడా you'll get minimum 6 marks or 7 marks. Those marks. Now coming to the next topic is characteristic curves of a centrifugal pump. Characteristic curves of centrifugal pump. Next. Coming to the characteristic curves, of the centrifugal pumps are defined as the curves which are plotted from the results of the number of tests of the centrifugal pumps. So curves allows for any pump or a turbine. So based upon the results, based upon the test results, you are getting the output. So for this, so the number of tests, how many number of tests to be conducted, based upon that the curves are obtained, right? Now see, these curves are necessary to predict what the behavior and the performance of the pump. So mainly characteristic curves pump gaani turbine gaani enduku chestamu, in order to see how many tests are carried on the pump and predict the behavior and also the performance of the pump when the pump is working under different loads, different flow rates, different head and different speed. అంతే కదా. ఇప్పుడు మీరు ఒక ఇంట్లో ఒక పంపు కొన్నారు, motor కొన్నారు. For example, in your lab you are having a pump or a motor. If you want to do any observations, so why you are doing observations? So in order to get the results, right? Whether the pump is performing good or not, what is the load capacity, how many tests we have performed. So like this we have to go for the pump performance. So like this, mainly the characteristic curves are generally used for testing the pump and the performance of the pump things. Now, what are the following important characteristics of the pumps? The first one is main characteristics, operating characteristics, constant efficiency or Mushel curves. So what are the main characteristic curves here? The main characteristic pumps of the centrifugal pump consists of manometric head HM. Keep this in mind, manometric head HM, right? The power and the discharge with respect to the speed. Now if you see the graph here, on x-axis you are having a speed, on a y-axis you are having a power, head and a discharge. Power, head and discharge. For plotting curves of the manometric head versus speed, discharge is kept constant. here the speed and discharge kept as a constant. For plotting the curves of discharge versus speed, HM is kept constant, and for plotting the curves of power versus speed, the manometric head and discharge are kept constant. Now see the which are kept at constant. The power is inversely proportional to the speed, right? Here the power H, the H manometric H is equal to constant, Q constant, and also HM is equal to constant. So generally you will not get any question in the mid exam, but if any question comes in the theory in the external exam, so what are the operating characteristic curves of centrifugal pumps అని ఇచ్చినప్పుడు you have to do what are the main characteristic curves of the centrifugal pump అన్నప్పుడు just draw the figure. Okay, just draw the figure, write the plot the x-axis, y-axis, and just draw the lines and just leave it. So మనకి ఎన్ని ఉన్నాయి characteristic curves లో? Main characteristics, operating characteristics, and constant efficiency characteristics. Next one is operating efficiency characteristics. So here some are kept at constant, and the variation manometric head, power, and efficiency with respect to discharge gives the operating characteristic of as shown in the figure, right? The input power curve for the pumps will not pass through the origin, so it can pass above, right? Will not pass through the origin. It will be slightly away from the origin on the y-axis, as even the zero discharge, some power is needed to overcome the mechanical losses. Therefore, the efficiency curve will start from the origin. Q is equal to 0, efficiency is equal to 0. Therefore, the efficiency is output by input. So whenever they ask the main characteristic curves, right, operating characteristic curves, you have to draw this curve. So on x-axis draw the discharge, on the y-axis draw the efficiency, power, and the head, show the lines. So this is the head, manometric head H, right? This one is a efficiency, right? This one is a input power, this one is a speed is equal to constant, that is the output power. So like this you have to draw the graph and leave it. Next one is constant efficiency curves. Next one is a constant efficiency curves. For obtaining the constant efficiency curve for a pump, the head versus discharge curves and efficiency versus discharge curves for different speeds are used. So I think you will not get this one, leave it. So characteristic curves are వచ్చినప్పుడు write 3 characteristic curves: main characteristic curves, operating characteristic curves, and constant characteristic curves. So in that, main or operating characteristics are important. Next concept in this multi-stage pumps is cavitation. So cavitation gurinchi morning afternoon first lecture 1 lo cheppukunnamo. So whenever the water the inlet veins are continuously under pressurized water, right? So whenever the water is flowing in the impeller and through the veins it is going outside, because of the air bubble rush, air bubbles anedi ఎక్కువ fan the vein blades starting point lo baga accumulate avutundi. So thereby what happens? The cavitation takes place. Now what is the meaning of cavitation here? The cavitation is defined as the phenomenon of formation of vapor bubbles, right? The phenomenon of formation of vapor bubbles of a flowing liquid in a region where the pressure falls below the vapor pressure of the liquid, falls below its vapor pressure, and sudden collapsing of the vapor bubbles in the region of the high pressure. Ekkadaithe vapor bubbles forms on the vein blade, on the vein exit blade, so whenever it suddenly collapses, what happens? The pressure అనేది అక్కడ burst అవుతుంది కాబట్టి at that point the cavitation takes place. When the vapor bubbles collapse, what happens? A high pressure is created. Then the metallic surfaces above such vapor bubbles collapse is subjected to these high pressures, which cause hitting action of the surface. Thus cavities are formed on the metallic surface, and also considerable noise and vibrations are produced. అర్థమైంది కదా? Very simple and straightforward. So cavitation question is the part A lo in the main exam. So simply you can draw a simple impeller, దానికి ఒక 2-3 veins వేసి ఆ veins edge లో టిప్ దగ్గర చిన్న చిన్న బబుల్స్ లాగా హోల్స్ వేశారనుకోండి, దట్ ఇస్ నథింగ్ బట్ ఎ క్యావిటేషన్. ఎలా వస్తుంది క్యావిటేషన్? సో వెన్ ఎవర్ ద వాటర్ ఈస్ పుషింగ్ ఫ్రమ్ ద ఇంపెల్లర్ సెంటర్ టు ద outside of the exit through the veins, so the pressure bubbles అనేవి ఎక్కువ ఆ టిప్ ఆఫ్ ద vein దగ్గర ఫామ్ అవుతుంది. సో బికాస్ ఆఫ్ దిస్ ప్రెషర్ డిఫరెన్స్, దిస్ bubbles will get blast. So whenever this pressure vapor bubbles blast అయినప్పుడు ఏం జరుగుతుంది? High pressure is created. When the high pressure is created, metallic surface మీద what happens? You are having some sort of rupture, some sort of eroded form జరుగుతుంది. Thereby it is subjected to high pressure, making some pitting action on the surface. Thereby the cavities are formed on the metallic surface, and cavities form అయినప్పుడు automatically sound వస్తుంది, vibrations వస్తాయి అన్నమాట, right? The cavitation includes the formation of vapor bubbles of the flowing liquid and collapsing of vapor bubbles. For formation of vapor bubbles of the following liquid takes place only whenever the pressure is in the region falls below the vapor pressure, right? Due to the sudden collapsing of the bubbles of the metal surface, the metal is subject to high local stresses, thus the surface or get damaged. So whenever the cavitation forms, what happens? Surface మీద stresses అనేది ఎక్కువ ఫామ్ అవుతుంది. So whenever the surface is getting stressed, automatically the veins will get damaged. Veins damage అయినప్పుడు replace చేయాల్సి వస్తుంది. Thereby the efficiency of the centrifugal pump will also decrease. Then what is the precaution you have to take against the cavitation? The precautions are: the pressure of the flowing fluid liquid in any part of the hydraulic system should not be allowed to fall below the vapor pressure. అంటే వేపర్ ప్రెషర్ కంటే తక్కువ లోపల ప్రెషర్ పడకుండా చూసుకోవాలి. The flowing liquid of water, then the absolute pressure head should not be below 2.5 meter of the water. What is the second one? The special materials or coatings such as aluminum, bronze, on stainless steel, which are cavity resistant materials, should be used. So మనం ఫస్ట్ పాయింట్ మనము నెగ్లెక్ట్ చేయలేకపోతే వేపర్ ప్రెషర్ గురించి. వాట్ ఇస్ సెకండ్ థింగ్? vein material అనేది should be very high grade. So the veins should be coated with stainless steel or aluminum, chromium, bronze, like that. Thereby these are anti-resistant material, cavitation resistant material, which will not create a problem for cavitation, right? Next, what are the main effects of cavitation? The effects of cavitation are: the metallic surfaces are damaged and cavities are formed on the surfaces. Next, due to the sudden collapse of the vapor bubbles, noise and vibrations are produced. Third one, the efficiency of the turbine decreases due to cavitation. అంతే కదా? సో వేన్స్ మీద బబుల్స్ ఒక వేన్ మీద ఒక 5 బబుల్స్ వచ్చాయి అనుకోండి, అట్లా ఒక రిమ్ముకు, ఒక ఇంపెల్లర్ రిమ్ముకు ఒక 10 వేన్స్ ఉన్నప్పుడు random గా ఒక్కొక్క వేన్ కి 10 to 15 హోల్స్ ఉంటే టోటల్ the efficiency of the centrifugal pump will get damaged. The efficiency of the turbine decreases due to cavitation. Due to pitting action, the surface of the turbine blades become rough, and the force exerted by the water on the turbine blades decreases. Therefore, the work done by the water or output horsepower becomes less, and efficiency also decreases. Next, cavitation in the centrifugal pumps. Cavitation in the centrifugal pumps లోపల cavitation ఎలా జరుగుతుంది? So if you see the Thomas cavitation factor of centrifugal pumps, the mathematical expression given with the Thoma, so sigma is equals to hv minus hs minus hls by h. That is equal to h atmosphere minus hv minus hs minus hls divided by capital H, right? Therefore, h atmosphere is equal to atmospheric pressure head in meters, hv is equal to vapor pressure, h is equal to suction pressure, hls is equal to head lost due to the friction suction pipe, capital H is equal to head developed by the pump. Based upon that, the following empirical relations used for obtaining the sigma c for different turbines. So ఒక్కొక్క turbine ki direct formulas ఇచ్చాడు అన్నమాట. So what is it for the Francis turbine? For Francis turbine, sigma is equals to, this is the formula. For propeller turbines, this is the formula you have to keep. For Francis turbine, whenever there is empirical relation, whenever the ns in rpm kilonewtons, whenever rpm in meters are given, for Francis turbine, this is the formula. For propeller turbine, this is the formula. So the cavitation method we'll see some of the problems, right? A Francis turbine has a mean manufactured to develop 15,000 HP at a head of 81 meter and a speed of 375. The mean atmospheric pressure is 1.03 and the vapor pressure is 0.03. Calculate the maximum permissible height. The critical cavitation factor for a Francis turbine is given by sigma value chart. Now, where n is equal to specific speed of a turbine in chemical unit. Then what's the given data? First, the given data clearly. Horsepower is 15,000. Horsepower developed with P is equal to 15,000. Next, head is equal to 81 meters. Speed is equal to 375 RPM. What is atmospheric pressure? Atmospheric pressure is 1.03 kgf converted into Newton per centimeters. That is equal to 1.03 into 9.81. That is equal to 1.03 into 9.81 into 10 to the power of 4. The atmospheric head in meter for water HM H atmosphere is equals to PA by rho G. What is the PA? PA is equal to this one. Atmospheric pressure divided by 1000 into 9.81, that is equal to 10.3. Now the vapor pressure PV is equals to 0.03. Convert into this one Newton per centimeter. This is the value. Now the vapor pressure, the head of the water HV is equals to PV by rho G. So after substituting, we will get the answer. Then the cavitation factor, this one is equal to already value shared. Now what you have to do? Substitute that. Therefore, NS is equals to n into root P by H into 5 by 4. So substituting the values here, so you are getting NS is equal to 189. Therefore, what is this one? This is also given that sigma C is equal to NS. Therefore, sigma C is equals to, what is this one? Sigma C, the cavitation formula is equals to this one. Therefore, you got the value of this one, you got the value of H atmosphere, HV minus HS divided by H1. Therefore, so even outside of this, the H1 value is equals to, HS value is equals to 0.08308. That is a process you have to do for this cavitation problem, right? Next topic in your syllabus is NPSH. What is the meaning of NPSH? Net positive suction head. Commonly used in the pump industry. So, meeku part A lo short answers lo vaste question raవచ్చు. Define NPSH or what are the factors of NPSH. So, you have to write this formula and you have to do this. So, NPSH is commonly used in pumping industry. Actually, the minimum suction conditions are more frequent specified in terms of NPSH. The net positive suction head is defined as the absolute pressure head at the inlet to the pump minus the vapor pressure head. Now, what is NPSH? NPSH is equals to absolute pressure head at the inlet of the pump minus vapor pressure head plus velocity head. For this, the pressure head P1 by rho G minus PV by rho G plus velocity head another kada velocity head V square by 2G. Therefore, absolute pressure at the inlet of the one P1, that is okay. From the equation, so P1 by rho G is equals to PA by rho G minus V square by 2G plus HS plus HFS. So substituting this into this equation, NPSH is equals to, so taking these values here, taking this value, keep on substituting. So you are getting this one. So finally, NPSH formula is equals to HA minus HS minus HSFS minus HV. This is the formula for NPSH. Now, if you see the centrifugal pumps work, if you see the formula, see the formulas. So, what is the hydraulic pump, centrifugal pump? This one, right? The work done is given as M. Work done is equals to 1 by G W VW2 into U2, where UT is equal to outlet, UT is equal to tangential velocity at outlet. The suction head formula. So, just me and chadukondi snippets laga panikosthundi. The suction head, the vertical suction head, the delivery head formula, the manometric HHM value, HM formula, right? The total head of the HM is equal to HS plus HT plus HF plus HFD. Next, the efficiencies. So we know we are having 3 efficiencies: manometric efficiency, mechanical efficiency, and the overall efficiency. So what is the manometric efficiency? This is the manometric efficiency, right? GHM by VW2 into U2. Next, mechanical efficiency is this one. Overall efficiency is this one. Okay. The minimum speed of a starting speed of a centrifugal pump formula. Then you have a problem just now, right? So like this, just read this one. I'll provide this slide for you. So ఒకసారి చదవండి. You'll get the net speed, so total values. So ఇది అవసరం లేదనుకోండి. The cavitation అంటే ఏంటి, characteristics అంటే. So actually we don't find time to, so these are some of the theoretical problems we'll get for the for your main exam also. So reciprocating pumps ఇంకా discuss చేయలేదు, but we'll take third class. No issues. I will record it or I will send you by tonight. So once మీకు slide ఇచ్చిన తర్వాత PPT, so that you can study on your own. Okay, so we'll stop the class here. So we'll discuss the class lecture 3 of this unit 6. I will post you in the YouTube. So tomorrow we'll discuss about unit 5 topics, right? So thanks.